Welcome to this quantum security and defense presentation, Entanglement-assisted quantum key distribution authentication, and thank you for being a valued member of our community. Julià Farré. Paul is a Spanish physicist with a bachelor from Barcelona. Then he specialized in quantum in the Quantum Science and Technology (QST) master program in Munich. He is currently working as an assistant researcher at TU Braunschweig in the field of quantum communication, and soon starting a position as a PhD student. His role concerns contributing in research papers and giving the tutorials for the lecture Quantum Communication Networks, lectured by Dr. Christian Deppe.
Farré is a physicist and he's specializing in quantum science and technology, and he's working at TU Braunschweig on the quantum communication, and he is specializing in the quantum authentication, and he will, I hope, explain all of that to us, and I hope we will be able to ask a lot of questions to learn about it. So Paul, I'm happy you're here, and the floor is yours.
Okay, thanks for the for the nice introduction and for the invitation. Am I audible?
Yes, I can hear you well.
Perfect. So yeah, I'm very happy to be here. Thanks for the invitation. And I'll be presenting a topic named Entanglement-assisted quantum key distribution authentication. I must say that this work is on revision, so some of the results I'll be showing today, we are currently not sure about their validity. So this is a very recent work, but I hope still that somehow you can learn a bit about what authenticating a QKD scheme means, and also what can it be tackled by. This joint recent work with Vlad Galetsky, myself, Sofam Ghosh, Janis Notzel, and Christian Deppe, and we come from either Technische Universität Braunschweig and Technische Universität Munich. So I will start with the outline. I will present a brief introduction of the topic. Later on, I will describe a paradigmatic and super famous, I would say, quantum key distribution protocol, the VB84 protocol. We will also see how entanglement can be seen as a means of trust in order to achieve authentication. In the third section, I will present our model to authenticate the VB84 protocol. And then I will contextualize our proposal. I will compare it with different works one can find today in the literature. And finally, I will conclude and motivate further research, which I anticipate that it's a lot because, the work is not completed. Let's start by defining quickly what quantum key distribution is. Most of you must be familiar with that concept. So when we have two parties that want to communicate secretly, we can achieve that by sharing a random binary key that we call key by just having this easy method. So we encrypt them a certain message M. We encrypt it by adding to it this key with the so-called XOR operation, and then we can decrypt it by applying the same key to the encrypted message. Okay, so that's a simple way to securely encrypt messages. This way, Bob and Alice can happily and secretly communicate with each other.
Watch the full presentation and other presentations from quantum experts at www.quantumsecuritydefense.com.